Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's have part 2 of lesson 2, mass function and expected value of a discrete random variable. Now, let's have an additional examples about PMF or probability mass function. Let's consider the following PMF. The PMF f of x is equal to 1 over 30 x squared if x is element of 1, 2, 3, and 4 and equal to 0 otherwise. Now, the question is, show that f of x is indeed a probability mass function or PMF. Now, for our solution, recall property 1. So by property 1, the PMF f of x is equal to 1 over 30 x squared must be greater than 0 for x element of 1, 2, 3, and 4. And the PMF f of x is equal to 0 for x not element of 1, 2, 3, and 4. So, the PMF f of x is greater than or equal to 0. The non-negative property of the probability mass function is satisfied. It means property 2 is satisfied. Okay, let's use property 2. The summation of f of x as x element of s is equal to the summation of the probability of x equal to x as x is equal to 1 up to 4. That is now equal to the probability of x equal to 1 plus the probability of x equal to 2 plus the probability x equal to 3 plus probability x equal to 4 is equal to 1 over 30 times 1 squared plus 1 over 30 times 2 squared plus 1 over 30 times 3 squared plus 1 over 30 times 4 squared. Simplifying both, we have 1 over 30 times 1 plus 1 over 30 times 4 plus 1 over 30 times 9 plus 1 over 30 times 16. That is now equivalent to 1 over 30 plus over 30 plus 9 over 30 plus 16 over 30, which is equal to 30 over 30 or equal to 1. The property that the sum of the probabilities is equal to 1 is satisfied. Therefore, f of x is a probability mass function. Since property 1, f of x is greater than or equal to 0, and property 2, that the summation of the probability of x is equal to 1, then we can conclude that the given f of x is really a probability mass function. Now, let's talk about expected value or mean of a discrete random variable. Take note, expected value or otherwise known as the mean or the average. Let's define an expected value. The expected value of a discrete random variable x, denoted by E of x, is equal to the weighted average of the elements x in the support S, where each element is weighted by its respective probability. To find the expected value, we use the formula E of x is equal now to the summation of x times f of x, where x is element of S. Take note, expected value is equal to the summation of x times the fx, the PMF, as x element of S. Let's have example number 3. Let x be a discrete random variable and s is equal to 0, 1, 2, 3 be its support. With the PMF of x given as f of x is equal to 1/4 if x element of s and equal to 0 if x not element of s, compute for the expected value of x. Now, for our solution, since the formula of an expected value is equal to the summation of x times f of x as x element of s, That is now equal to the value of x is 0 times f of 0 plus 1 times f of 1 plus 2 times f of 2 plus 3 times f of 3. Now, let's simplify. 0 times 1/4, that is now equal to 0. And then 1 times 1/4 is 1/4. Plus 2 times 1/4 is 2/4. And plus 3 times 1/4 is 3/4. Then, when we add, the sum is 6/4 or 1.5. Therefore, 1.5 is the expected value or the average. Now, let's have example number 4. Let x be a discrete random variable with support s equal to 1, 2, 3. Compute for the expected value if the PMF of x is f of x is equal to 1, 6x if x element of s and equal to 0 if x not element of s. Solution. Expected value is equal to the summation of x times p of x equal to x, or the probability of x equal to x. Take note, class. F of x is also equal to the probability of x equal to x. Now, E of x now is equal to the first support is 1 times P of x equal to 1, meaning the probability of x equal to 1 times 1 plus 2 times the probability of x equal to 2 plus 3 times the probability of x equal to 3. That is now equal to 1 times 1 over 6 times 1. You substitute 1 in the variable x. Plus 2 times 1 over 6 times 2 plus 3 times 1 over 6 times 3. That is now equal to 1 over 6 plus 4 over 6 plus 9 over 6. When we add, the sum is 14 over 6 or 2.33. 2.33 now is the expected value or the mean. Okay, let's have example number 5. A researcher surveyed the households in NHA population. The random variable x represents the number of college graduates in the households. The probability distribution of x is shown below. Find the expected value of x. Now, given this distribution, let's determine the expected value. Now, take note. Our random variable is 0, meaning 0 graduates in a given household whose probability is 25% or 0.25. If x is equal to 1, meaning there is 1 graduate per household and the probability is 50% or 0.50. And x is equal to 2, meaning there are 2 graduates per household and the probability is 25% or 0.25. Solution. First, let's make a table like this. So let x be our random variable 0, 1, 2, 3, and the probability of x is 0.25, 0.50, 0.25. And the formula in getting the expected value is x times p of x or f of x, right? So let's multiply x and p of x. That is now 0 times 0.25 is 0, 1 times 0.50 is 0.50, 2 times 0.25 is 0.50. Adding these 3, we have 1. So therefore, the expected value is 1. It means that the average number of college graduates in the household of NHA population is 1. Now, let's have additional example. Let x be a discrete random variable with support s equal to 1, 2, 3. Let the probability mass function of x be f of x is equal to 1 over 14 x squared if x element of s and equal to 0 otherwise. Question is, compute the expected value. Solution. The formula for the expected value is equal to the summation of x times the probability of x equal to x as x element of s. Okay? So the support are 1, 2, 3. So let's substitute. So x is equal to 1 and times the probability of x equal to 1 plus 2 times the probability of x equal to 2 plus 3 times the probability of x equal to 3. So if we substitute the value of x or probability, that is now 1 times over 1 over 14 times 1 squared because there is x squared plus 2 times 1 over 14 times 2 squared plus 3 times 1 over 14, 3 squared. Simplifying, we have now 1 times 1 over 14 because 1 squared is 1 plus 2 times 1 over 14 times 4, that is 2 squared, plus 3 times 1 over 14, 9, that is 3 squared. We have now 1 plus 8 plus 27 over 14, or equal now to 36 over 14. Or that is now 2 and 4 over 17. And that is now the expected value or mean of the random or discrete random variable. Thank you for watching. See you on my next video. Bye.